Hello, this is the second part of a two-part instructional video demonstrating how to set up a breadboard with 3 tactile switches, 3 LEDs, and 1 photocell to interact with a range of programming environments on a Raspberry Pi version 2. Here's the breadboard circuit that we built in part 1 of this series. Make note of the pins associated with the LEDs and tactile switch buttons, as we'll be needing this info for our scripts. We'll be working in Scratch for this exercise. To begin, we need to configure the pins 5, 6, and 13 to be output pins. We do this by creating a module that will run once when the green flag is pressed in Scratch. The broadcast control tile is used for this. In the drop-down, click New/Edit, since this is a new script that knows nothing about the GPIO pins by default. In the pop-up box, enter config 5 out, since pin 5 connects to the blue LED and we'll want to send 3.3 volts out to it when we turn it on later. Repeat with the additional broadcast blocks to send a config 6 out and a config 13 out. Next, bring over a broadcast block, choose New/Edit, and enter config 17 in, as pin 17 is connected to the tactile switch connected to the orange jumper cable, and we'll want to read in when that button is pushed. Repeat for config 27 in, the purple button, config 22 in, the yellow button, and config 21 in, the photocell. We won't do anything with the photocell in this exercise, but it's good just to make this a habit. We're now done with that module, and you can push it off to the lower right. It should run whenever the green flag is pressed. So now let's start a new module to test the LEDs one at a time. To do this, we'll again set up a broadcast, this time within a forever loop. In the new broadcast tile, choose New/Edit from the drop-down, and this time enter in GPIO 5 on to turn on the blue LED. If all goes well, when the green flag is pressed, the blue light should come on and stay on. Let's now change that broadcast by doing a New/Edit again and adding in a GPIO 6 on. If you didn't hit the stop symbol, the module still will be highlighting in white and is still active. So right away you should see the red LED come on. But notice we didn't issue a GPI 5 off, the blue light stayed on. If we change the broadcast again, this time to GPIO 13 on, the green light should come on as well. But what if we only want the green light on? Then what we can do is create a new broadcast message of GPIO 13 on, space GPIO 6 off, space GPIO 5 off. So we can put all 3 of those commands in one message. After hitting OK, we should have only the green light on. Now we'll move to testing the tactile switches, but before doing so, you might want to broadcast a GPIO 13 off. If any of the LED lights didn't come on as expected, it's time to troubleshoot. Look for connections on the breadboard that might be somewhat loose, a jumper wire connection in the wrong pin on the cobbler, or typos in the config out or GPIO on broadcast commands. That's where mine have been. Also make note if it's a problem with just one LED or all LEDs. If all, then perhaps there's a problem with the connection between the cobbler and the Raspberry Pi, for instance. So to test the tactile switches, we need a different test, since they are an input and not an output. To do that, let's use a forever loop and insert inside a say for 2 seconds tile from the Look tab. Obviously, saying hello for 2 seconds isn't going to do us much good. So let's go to the Sensor tab, grab the Slider Sensor Value tile, and drag that into the Say variable box, replacing hello. In the drop-down next to the slider variable, you'll see the 4 GPIO input pins that we configured earlier using the config 17 in, config 27 in, config 22 in, and config 21 in, corresponding to the orange button, purple button, yellow button, and the photo cell respectively. Choose GPIO 17 to begin with. Once you do, the sprite should have a say box saying, pop-up saying 1, as it's the normal state for these tactile switches. If you don't see the cat saying anything, try pressing the green flag to make sure the script's running. Once you see the 1, press the orange button, and if all is working properly, the cat should now say 0 for 2 seconds. If you've released the button once it turned to 0, in 2 seconds it will go back to 1, because again, that's the normal state for those tactile switches. Change the sensor to GPIO 22 and try the yellow button. Then change over to GPIO 27 and try the purple button. If you don't get the expected results, switching from 0 to 1 whenever the button corresponding to the GPIO pin is pressed, do some troubleshooting until you do. Common errors that are that one of the legs under the switch didn't go into the hole but got bent underneath the switch. The ground pin and pin connecting over to the GPIO cobbler might not be at opposite corners, or the pin connecting to the GPIO on the cobbler isn't in the pin expected. It could also be a typo in the config or GPIO broadcast or sensor statements. I say common for these errors because I've made each error myself again also. And again, an error with one button might lead to a different type of troubleshooting than if you have an error with all of the tactile switches. Once everything is working as expected in our test, you can next try some more advanced scripting. Both of the Scratch scripts that I'm going to show you are available for download. See the embedded link in the lower right part of the screen to be able to access those. This first script will tell us which button was sensed and flash a corresponding light 10 times before prompting us to try again with a message for 2 seconds. After that message goes away, you can press the next button. The orange button turns on the blue LED, the purple button, the red LED, and the yellow button, the green LED. Just like that. The second script adds a third module. Module 1 does the config in and outs. The second module starts a repeated pattern of LED flashes when the yellow button is pressed, and stops that pattern if the orange button is pressed at the end of the green LED on phase, that is, at the end of the repeat cycle of flashes. Pressing the yellow button starts the pattern again, and then the final module is activated if the purple button is pressed. It turns the LEDs on and off in a crazy pattern while also having the sprite run around on the stage. At the end, it turns off all the scripts. That's the end of this demonstration. So what do you think you might do now that you've seen the basics how to work with these LEDs and tactile switches? I look forward to hearing.